Hello aviators, welcome to Aviation Education. So today we are starting with the second chapter of air navigation, which is the Earth. So the shape of the Earth is oblate, compressed, spheroid or ellipsoid. So as you can see in the picture, the Earth is not perfectly sphere. It is slightly flattened at the poles. It is because the Earth's polar diameter is approximately 23.5 nautical miles shorter than the equatorial diameter. And here we can see that the polar radius is 3432 nautical miles, which is equivalent to 6356 kilometers. And the equatorial radius is 3443 nautical miles, which is equivalent to 6378 kilometers. After that, we have the compression ratio. So the compression ratio is basically ratio between the polar diameter and the equatorial diameter, and it also indicates the amount of flattening that the Earth has. So for the Earth, this approximate ratio is 1 upon 297, and we just count it for easier calculation. We count it as 1 by 300. So for every 300 unit of the equatorial diameter, the polar diameter is less by 1 unit. And the ratio of ellipticity. So the compression ratio, second name is the ratio of ellipticity. And the formula is the major axis minus minor axis upon the minor axis. And when viewed from the North Pole, the Earth rotates anticlockwise from west to east, and when viewed from the South Pole, Earth rotates clockwise east to west. So if you take any round surface and if you rotate it and you look it from above, it will go anti-clockwise, and if you look it from below, it will go clockwise. The next topic is the latitude. So the angle subtended by the shorter arc of the meridian from equator to the point to be identified. So the angle that is made by the shorter arc of the meridian and the equator to the point to be identified is known as the latitude. So there are parallel of latitudes. The line joining the points of equal latitudes are called parallel of latitudes. And we have total of 1 to 89 degree north and south of the equator. And there is 90 degree north and 90 degree south, which is known as the North Pole and the South Pole. After that, we have two types of latitude. Because the Earth is not perfectly spheroid, we can calculate latitudes in two different types. Okay, so the first is the geocentric latitude. So the geocentric latitude is the smaller angle between the center of the Earth and the plane of the equator. And the geodetic latitude is the angle between the normal to the meridian at the point of spheroid and the plane of equator. And the geodetic latitude is used in the charts. So we don't, for the DGC exam purposes, we don't really need to remember these definitions. But the next point we need to remember, which is the maximum difference between the geocentric and the geodetic equator, is at 45 degrees north south, and it is about 11.6 minute arc. So the difference is maximum at 45 degree north and south, and it is 11.6 degrees arc. So the next topic is the longitude. So the angle subtended from the center of the Earth by the shorter arc of the equator from the prime meridian to the point to be identified is called the longitude. So let's see on the picture, the P is the prime meridian, the A is the point to be identified, and the P and A is making an angle to the center of the Earth. So it is 50 degrees. So the A is 50-degree longitude. And after that, we can see that there are meridians. So meridian is basically the line joining the point of equal longitudes. And we have 0 to 180 degree east and west of the meridian. So from the prime meridian, which is 0 degree east west, which passes through the Greenwich, London, the east side goes to 180-degree east and the west side goes to the 180-degree west. So we have total of 360 longitudes. After that, we have the anti-meridian. So the meridian that is 180-degree opposite of any specific meridian is known as the anti-meridian. So let's take an example of 010 east. So the anti-meridian would be 170 degrees west. After that, we have the coordinate system. So the coordinate system is basically how can we point out any point on the earth? How can we say which point on the earth we are on? So to say that, the latitudes are shown in X and the longitude are shown in Y. Let's take an example. So we have 23 degrees 07 minutes 64 minute north and 72 degrees 63 minutes 10 seconds east. So this is the coordinate of a specific point on the earth. It is shown in degree, minutes and seconds, north or south and east or west. After that, we have the graticule. So what is a graticule? Graticule is basically when there are two meridians and two parallel of latitude. Then it is any meridian or any parallel of latitude, they make a shape. So here in the picture, we can see the GQAP is creating a something like a square shape. So they are known as the graticule. And any meridian or the parallel of latitude can make it. After that, we can see here that along the latitudes, aircraft flies the true east-west track. So basically, it means that if we fly on the latitude and we keep flying on the latitude, we are either flying 090 degree or we are flying 270 degree direction. And if we are flying on a longitude constantly, then either we are flying 000 degree or we are flying 1 at 0 degree. And okay, I hope you understood this. After that, we also have one another picture. So here we can see that the latitudes are the horizontal lines and the longitudes are the vertical lines on the earth surface. We represent it on the earth surface. They are present on the map or charts. So let's see what is a great circle. So great circle is any circle whose plane divides the earth into two equal parts. And there are different properties of this great circle. The first is that the smaller arc of the great circle is the shortest distance between 2 points on the earth. And we often use it in aviation to go from one place to another. And the second property is that it appears straight line on the earth surface. After that, we can see that only one great circle is there joining any 2 points unless they are diametrically opposite. So if there are 2 points on the earth surface, there can only be one great circle between them. But if they are diametrically opposite to each other, there can be infinite great circles joining them. And the radio signal follows the great circle path. So any radio signals follows the great circle path. It can be for the instrument or the radios that we talk on. And the last is that any circle other than the great circle on the earth surface is called the semi-great circle. So any parallel of latitude other than the equator is a semi-great circle. And one meridian and its anti-meridian creates a great circle, and any one meridian, only a meridian, is a half great circle. So let's learn about the Rhumb lines. So a Rhumb line is a line which cuts all the meridian at equal angle. And the properties of Rhumb line is along the Rhumb line, the aircraft follows a constant direction. So if we are flying on a Rhumb line, we follow a constant direction. And the Rhumb line is not the shortest distance between the 2 points. and any rhumb line spirals towards the nearest pole. So if there is a rhumb line in the north hemisphere, it will spiral to the north pole, and if it is in the south hemisphere, it will spiral to the south pole. And any parallel of latitudes are rhumb line, and only equator is both the great circle and the rhumb line. After that, we can see here two statements. It is mostly used for the solving of the numericals. So it is d-lat. Now d-lat is the difference in the latitude. When the longitude is constant, the difference in the latitude is called as d-lat. And when the latitude is constant, the difference in the longitude is known as d-long. So, this is all about the third chapter of air navigation, which is the Earth. I hope you all understood it.